We're going to solve the polynomial inequality right here. And then we're going to take the solution set, we're going to graph it on the number line, and then we're going to put it in interval notation. So this is a polynomial. It is an inequality, greater than. So first thing you need to do, make sure you have a 0 on one side, which we have, and smiley face. And the second thing is make sure that we factor the polynomial. So this could trick somebody. When you go to factor this, remember the first step in factoring is GCF, greatest common factor. There's only two terms here. So if you look at those two, do they both have something in common that I can factor out? They sure do. What is it? It's an x. If I factor out the x, I'm left with x minus 4. And now you can see that here are your two factors. Okay, so it's already factored. I don't have to do anything else. The next thing we're going to do, we're going to go to our number line. We're going to put our boundary points, which are going to be, I'm going to get a 0 here and a 4 here. All right, what would I plug in to get 0 for the whole thing is 0. What would I plug in to get 0 for the whole thing is 4. So I'm going to put down a 0 and a 4. All right, 0 has to be on the left of 4. And now I'm going to test a point on every possible interval. So I'm going to test a point back here, one in here, and one over here. All right, let's try -1, and then let's try 2, and then let's try 5. All right, whatever the test point gives me is going to tell me if the whole interval is part of my solution or not. All right, so I'll go back to the original equation, put it down here, and let's go ahead and plug in. All right, so instead of x, I'm going to plug in a -1. So here I will have -1 squared minus 4 times x, and that's going to be a -1. All right, -1 squared is going to be -1 times -1, which is 1. Minus 4 times -1 is going to be plus 4. And you know that 1 plus 4 is greater than 0? So 5 is greater than 0. Is 5 greater than 0? Yes. So everything in this interval is going to be part of my solution. All right, so everything from -infinity to 0. Let's test this interval right here, in between 0 and 4. I'm going to use the number 2, and that's going to tell me if it's a yes or a no. So everywhere I had an x, I'm going to plug in a 2 and a 2. 2 squared is 4. Minus 4 times 2 is 8. 4 minus 8 is -4. Is -4 greater than 0? Answer is no. So this is a no, and I'm not going to shade any part of this interval right here. All right, one more time. Let's go ahead and do it again. Let's use the number 5 as my test point. All right, I'm going to use a green. Everywhere where I had an x in the original, I'm going to put in a 5. 5 squared is 25. Minus 4 times 5 is 20. 25 minus 20 is 5. Is 5 greater than 0? And the answer is yes. So everything in this interval needs to be shaded, and it is part of my solution. Okay, so that's everything between 4 and infinity. Now, the 0 and the 4, do they get a bracket or a parenthesis? And I'm going to find that out by looking right here. Okay, if it's strictly greater than, I'm going to get parentheses. If it was greater than or equal to, then I would have a bracket. So this is going to be a parenthesis on the 0 and a parenthesis on the 4. Interval notation. If my graph is done correctly, my interval notation is just going to come straight down. So I can see that I have one interval from -infinity to 0, and I have another interval from 4 to infinity. So -infinity to 0, parenthesis, parenthesis, in union with 4 to infinity. All right, and to see what this is all about, I'm actually going to graph this polynomial so you can see for yourself when it is greater than 0. Okay, so this is kind of like a check. If you want to go into Desmos and you want to graph it with the Desmos graphing calculator, that would be a great idea. All right, and if you look right here, what I'm circling in yellow, this is what the graph of this polynomial is, of x squared minus 4x. When is it greater than 0? Well, it's greater than 0 at these points right here that I'm going to put in pink. It's not greater than 0 right there at 0, but as soon as I go above, it's greater than 0. Same thing here, greater than 0. Okay, so you can see that the intervals where it's greater than 0 is all of this stuff. It goes forever to the left, and in all of this stuff, it goes forever to the right. So that's the part where it is greater than 0, and that makes sense when I look at my solution.